Good morning, Year 10. Today's lesson is going to be on important algebraic objects. I want you to learn all of the different words in this video for naming the different algebraic objects. Tomorrow's lesson is going to be a live lesson where we talk about the test that you did yesterday. But today is more of a sort of vocabulary lesson and understanding the difference between different types of mathematical objects. On the board, I have written x squared plus 3x plus 2. There are lots of algebraic or mathematical objects in what I've written here. Pause the video now and see how many of them you can name. For example, 2 is a constant. That helps you to name any of the others. X is a variable or a generalized number. Three is the coefficient of x. It's the number multiplying x, so it is a coefficient. The addition signs are operators. If there were subtraction signs, division signs or multiplication signs, they would be operators as well. Although, as you know, in algebra we don't write the multiplication sign. Each of these three things, so x squared, positive 3x and positive 2, they are all terms. And overall, this entire thing is an expression. So the whole thing is an expression. So overall, even though it was just one object in the first place, there's loads of different algebraic objects. The whole thing is an expression. That is important. It is different to an equation. We'll talk about why in a minute. The terms are the different parts of the expression, and if it's a plus or a minus sign in front of the term, that is attached to it because it tells us if it's a positive term or a negative term. The addition signs are operators. X is a variable or generalized number. 3 is the coefficient of x. X squared does not have a coefficient. Well, I've said that wrong. What is the coefficient of x squared? Coefficient of x squared is 1, because when we have 1 times something in algebra, we just don't bother writing the 1. So x squared's coefficient is 1, but it is not there. And then this is a constant term. It is 2. It's called a constant because there is no variable. So this does not vary. It is constant at 2. It's always 2. So 2 is a constant. 3 on its own would be a constant, but it is attached to a variable here. So 3 becomes the multiplier or the coefficient of x, and x is a variable. So this term does vary. We can evaluate an expression. So for example, I could evaluate this expression when x equals 2, and I would just substitute x equals 2 into this. So I'd have 2 squared plus 3 times 2 plus 2, so I would have 4 plus 6 plus 2 is 12. Question then for you to pause and have a quick think about is, do you know what the difference is between an expression and an equation? So this is the expression that we were just looking at. To make it an equation, I can do this. An expression does not have an equal sign. An equation does have an equals sign. So again, this would be an expression. I can evaluate it. It has terms, it has operators, it has a variable. It doesn't necessarily have to have a variable, just 2 on its own could be an expression. But 3x plus 1 is an expression. It has a coefficient of x, it has a constant term. To make it an equation, I need an equals sign. And it could be a number here, or it could be another variable. So you are used to seeing this type of equation when we are dealing with graphs, for example. The type of equation we have changes what we call x. So in the expression, x was a variable or a generalized number. In an equation, this is now a variable. We can vary the value of x, and that will vary the value of y. So if I put x is 1 in here, we would have y equals 4. If I put x is 2 in here, we would have y equals 7. So x is a variable. However, if I had the same expression on the right-hand side, but the equation looked like this, x is not a variable anymore. We can't vary x. There is only one value of x that this works for, and that value is 2. So in this case, this is an equation. This is a constant term. This is a constant term. 3 is the coefficient of x, but x is now an unknown. It's not a variable because it can't vary. X can only be 2, but we don't know x is 2 at the beginning, so it is an unknown in the first place. It's also easy to forget about the equals sign. The equals sign is really important because it tells us that this side of the equation has the same value as this side of the equation. A special type of equation is a formula. So formulas look very similar, formulae I should say, look very similar to equations. They often have the same sorts of components. They have an equal sign, which is a fundamental part of an equation. Then they have variables. They might also have constants, and they might also have coefficients. Formulae is something you see more in physics. It is a relationship between variables that I suppose is always true. Whereas an equation doesn't necessarily even have a variable. Like I said here, x would be an unknown, and we would solve this for x. Sometimes we'll be given numbers that we can substitute in the two formulae to solve other parts of the formula, but a formula generally is a relationship between variables. So what that gives us then is an expression. We'll have, or could have, a variable or generalized number. Could have coefficients and constants, and it will be made up of terms. Oh, and also operators. When we get to equations, we can still have all of the above, but we also need an equals sign. And where there's a variable or generalized number, it might actually be an unknown that we have to solve for. Then finally, for formulae, it is just a special type of equation. So those are the important bits of algebra vocabulary you need to learn. There's going to be 2 more bits, but have a look at those first. Try to write an expression and an equation and label each of those things. Try and include each of these things within your expression and try to include all of these things and these in your equation. Obviously, you can only have an unknown variable or generalized number because they all look sort of the same. Don't worry about formulae, although you could try and write down a formula that you know from physics. So write down an expression and an equation using all of these for the expression and all of these plus these for the equation, please, and label them. And that is going to be part of the work that you have to submit. Have a look at this mathematical object then. Pause the video and decide firstly what is the overall object, and secondly try to label all of the things that you can within this object. So pause and do that, then come back because I'm going to do that now, and if I miss one, leave a comment on Show My Homework and let me know. So overall this is an equation because it has an equal sign. X in this case is not an unknown, it is a variable, because X could be any value and then that will give us Y as any value. Y is also a variable. Now, bonus, X is the variable that we would plug different values into, so that one is independent. Y will depend entirely on what we put in X. So Y is the dependent variable. The coefficient of x squared is not written down, it's just 1. 2, including plus, is the constant term. Y, x squared, and positive 2 are all terms. And then the addition sign is an operator. Two more objects that you need to know are not equal to and the identity symbol, or equals. It's not an equals, it's the identity one, but they mean similar things but not the same. Not equal to is very easy to understand. We know that 2 plus 3 equals 5, in which case 2 plus 3 does not equal 6. That's all we would use it for, is to signify that what's on the left hand side is not equal to what's on the right hand side. So another one, we could say 7 minus 1 does not equal 100. And hopefully, being in set 1, you know that that's true. So that is all the not equal to sign is used for. So, the identity symbol. We've just been looking at equations. So let's have a look at this equation. X minus 1 equals 2. This is an equation. In this particular equation, x is an unknown. Now, this equation is not always true. The only time this is true is when x equals 3. So we just use the equality sign. However, if I wrote this, x plus 1, I can use the identity sign. X plus 1 equals 1 plus x, whatever the value of x is. So this is always true, so I can use the identity symbol. And that is what the identity symbol represents. It means that each side is always true. Now, a common question when I do this with students is, why don't we write this? The The reason we don't write this is because it's not always true. It depends what we're operating in. For example, let's say we're using a 24-hour clock and it is 11 p.m. So that is 2300 hours. Now, if we add 6 hours to that, it does not turn into 29 on the 24-hour clock, because the 24-hour clock only goes up to 24 hours. If we do 23 plus 6 on a 24-hour clock, we actually end up getting to 5 a.m. So in the 24-hour clock world, the number 29 does not even exist. Therefore, we can't say 23 plus 6 is always equal to 29, because it's not true. So, as an example, in each of these equations, can we replace the equals sign with an identity symbol? Let's have a look at this one. In this one, this would really mean that this equation would mean that x is an unknown, because we can solve this equation. If we solve this equation, I'm going to subtract x from both sides. I'm going to subtract 6 from both sides. So we end up getting that x is only negative 1. So this is only true when x is negative 1. So no, we can't replace the equal sign with an identity sign, because this equation is not true for all values of x. What about this one? The left-hand side turns into x squared minus x. The right-hand side turns into negative x plus x squared, which is the same. And actually, if I tried to solve this, I would add x to both sides and I would subtract x squared from both sides and end up with 0 equals 0, which is always true. So yes, I could replace this with an identity sign, because this side is x squared minus x, and this side turns into x squared minus x. So it is an identity. This example should help you do question 1 from the exercise that I've put on Show My Homework. I'm going to now do another example which will help you do questions 2, 3, and is there a 4th question? Yes, 4. So for this example, we need to find the value of k if x plus 2 multiplied by x minus 3 is always equal to x squared minus x plus k. So we need both sides to be exactly the same, essentially. So I'm going to multiply out this left-hand side. And that will turn into x squared minus x minus 6. Now if we want this side, x squared minus x minus 6, which has come from multiplying this out, to always be equal to x squared minus x plus k, then we have to compare the two sides. I've got x squared on both sides. I've got minus x on both sides. So this negative 6 must be equal to this plus k, which means that k must be negative 6. For these two sides to always be equal, k must be negative 6. If k was something else, it would be an equation for us to solve, but for it to be an identity, it needs to be the same on both sides. That should now be enough for you to do questions 2, 3 and 4. So I'd like you to pause the video and have a go at all of the questions in the exercise. I am going to do question 3. I don't want you to watch it yet. I would like you to have a go at it, but I'm going to do question 3, and then that will help you with question 4 if you find question 3 difficult, and you can also check your answer. So pause the video now and do the exercises, and then come back to it. I'm going to do question 3. So at the top is what's written in question 3 that we have to prove. When you are proving something, you must only use one side and try to get to the other side. So I cannot write the whole thing out every time. I'm going to start with the left-hand side in this case and see if it turns into the right-hand side when I multiply it all out and simplify. So I'm multiplying out this x plus 5 squared, which gives me x squared plus 10x plus 25. And I'm going to add 3. I'm going to multiply out this x minus 1 squared, so x squared minus 2x plus 1. So I've got the x squared plus 10x plus 25. And now I'm going to multiply this out. So I've got plus 3x squared minus 6x plus 3. Simplifying by collecting like terms, I've got 4x squared plus 4x plus 28. And I want that to turn into this, hopefully. So if I have a look at what's happened here, they've factorised out of 4. So if I factorise 4 out of mine, I get x squared plus x plus 7. And now if I compare that to the question in the first place, see that my answer matches the right-hand side. So something you would want to do there is say equals right-hand side, and here you could have started by saying left-hand side equals. So you've ended up showing that the left-hand side does turn into the right-hand side. So that is how you would do question 3. Use that to help you do question 4 if you haven't done it already. And the questions I want you to submit then are the one that I asked you about expressions and equations at in the first part of the video, and exercise 1, which is questions 1 to 4, please. If you get stuck or you don't know how to do something, please leave me a comment on Show My Homework.